13, question 6a. A rectangular block of wood of mass 20 kilograms and height 2 meters floats in liquid. The block experienced an upward force of 400 d newtons, where d is the depth in meters of the bottom depth of meters at the bottom of the block below the surface. So we can see that d is just here. Okay, this what are we going to say? This level here, just below the surface. That's the height of d. Okay. Next thing is find the value of d when the block is in equilibrium. Okay, so when the block is in equilibrium, lads, what we should have is we should have a weight equal to your buoyancy. Okay, but weight is going downwards and buoyancy is going upwards. Okay, so weight is going downwards and buoyancy is going upwards, right? So the weight of the object is 20 kilograms, 20 kg. Okay, so 20 kg, or sorry, 20 g, because it's mass times gravity. Okay, and then it says it experiences a buoyancy force of 400 dN. So 400 d there. So this implies that d on its own is 20 g divided by 400. Okay, and then 20 g divided by 400, so 20 times 9.8 divided by 400 is 0.49, so d equals 0.49. Okay, so we've had to find out what d is quite quickly. Okay, so that is done. The period of the motion of the block is pushed down another 0.3 meters from the equilibrium position and then released. Okay, so we have to find the period of the motion, which is 2 pi over omega, if the block is pushed down another 0.3 meters from the equilibrium position and then released. Okay, well, the first thing we need to do is we need to find out its simple harmonic motion. So instead of using the 0.3 meters, we're actually going to use an extra distance, x. So what we're going to do is we're going to push the block underwater. Okay, so imagine this is our marker here. We'll just do this in red. This little marker here is x above the line. This little marker is going to be here, so now it's going to be d plus x. This means the buoyancy force is no longer 400 multiplied by d, because d is no longer the depth. It's 400 multiplied by d plus x. The weight is still 20 g's, and we're going to have to set up our simple harmonic motion. Okay, now which one is the larger force? Well, the larger force is the buoyancy going upwards, and the smaller force will be the weight going downwards. So to get a negative value, which is what we're looking for when we're looking for omega squared x, what we're going to say is that we're going to have to start off with forces actually. So it's going to be ma, which is your net force, is going to be force down minus force up, because that will give us our negative value that we're looking for, because we want it to be minus omega squared x. So it's going to be ma, which is going to be 20a. Your force down is still going to be your 20 g. However, your force up is going to be your minus 400 d plus x. Okay, but the good news is we know what d is. D is 0.49. Okay, so that makes this quite easy. Multiply minus 400 by 0.49. And we should get something equivalent to 20 g, so it's going to be 400 times 0.49 is 196, and oddly enough 20 times 9.8 is also 196, so they're both 196. And then we're going to get minus 400 x, which is no bother, equals our 28. And then next thing after that is we're going to get a 28 equals minus 400x. And then we're going to find out that a equals minus 20x, because 400 divided by 20 is in fact 20. Okay, so a equals minus omega squared x. This implies that omega squared is 20. This implies omega equals root 20, and we all know that root 20, when you throw it into the calculator, gets you 2 root 5. Okay, so then we're looking for the periodic time. Time equals 2 pi over omega. T equals 2 pi over 2 root 5. So the periodic time will be pi over root 5 seconds, or 1.4 seconds. Okay guys, that's it, pretty much done. That's a pretty easy one in the end. That was 2013 6A.